All right, Yeji, what'd you get for number 1? Well, Yeji has a chance to type. What you would do first on number 1, 9 is not divisible by 5. So you would need to separate these for sure. And then you play I Spy and you look for perfect squares. Can you spy one? So yes, you should spy a perfect square, yep. So this is 3 over root 5. And then you go through your checklist. Is that a simplified answer? And you're like, oh man, it's not good. Good, Yeji, that's right. Oh man, it's not a simplified answer because I've got a radical in the denominator. So then we have to do that thing called rationalizing. And Yeji, you got it right. So number 1 is going to equal the denominator, square root 5 times square root 5. 5. 3 times square root 5. So there's our final answer, 3 root 5 over 5. Perfect. Jenny, number 2. The square root of 9 is 3, Tahani, but that's not the answer to number 1. It's 3 root 5 over 5. Oh, okay. So Tahani, that's one of the biggest things we learned on Monday, is that when you're multiplying radicals, 3 times square root 5 is not 15. 3 times square root 5 is 3 root 5. You can't, numbers cannot go into the radical and numbers cannot come out of the radical when you're multiplying. You multiply the numbers outside and you multiply the numbers inside and you keep them separate. Like oil and water. You keep them separate. They separate themselves naturally. Jenny, you got 6? Okay, 2 has a trick to it, and we did a lot of these yesterday. 24 is divisible by 6. So when they're divisible, go ahead and combine them. Go ahead and divide them. So I'm going to rewrite number 2. 24, I can honestly do this. I would need to rewrite it, but we're okay. 24 divided by 6 is 4. So number 2 is really 3 root 4, which is really 3 times 2, which is 6. So very good, Jenny. 6 is the answer to number 2. 4 is a perfect square. So instead of writing square root 4, you write 2. Minjung, number 3. Sorry I gave you the hardest. That won't get any smaller for me. You have no idea. Okay, let's work on these one at a time. What about that first one, 3 root 2 over 5? Is that fully simplified? Yeah, it's fully simplified. So don't do anything to the first one. Now this one, the second one, needs some work. This is the square root of 2 over the square root of 5. We need to rationalize the denominator by doing that. Square root 5 times square root 5 is 5. Now, Tahani, here's where you get to multiply. The square root of 2 times the square root of 5 is the square root of 10, because 2 is in a radical and 5 is in a radical. So there is our simplified radical on that one. Okay, so we've got 3 root 2 over 5 plus root 10 over 5. So go back to your algebra days, your days in algebra. You can add fractions when you have a common denominator, right? You can add them. Algebra, common denominator. These have a common denominator. Now, look at the numerator. Are the numerators like terms? Are they like radicals? No. Root 2 and root 10, that's an apple and an orange. You cannot combine them. Don't say root 12. It's not how it works. That's an apple and an orange. You cannot combine them. You've got 3 apples and 1 orange. How many do you have? Well, you have 3 apples and 1 orange. You don't have 4 apple oranges. So, our final answer is 5 is for sure the denominator, and then there's our numerator. So believe it or not, that is the simplified answer to this problem. You can't, yes, Taha, you're right. You cannot combine root 2 and root 10. Don't do it. Let's move on to the homework. So it was Pythagorean Theorem, which was nothing new. But what was new about it was leaving our answers in simplified radical form. We've never done that before because we didn't know how to simplify radicals before. So none of your answers should have been decimals. Your answer should have been exact. And that's what's so cool about knowing how to simplify radicals. Your answer is not approximate, it's exact. And we love exact. Exact is always better. Not always. Most of the time. Okay, so from the Pythagorean Theorem worksheet, starting with number 2, square root of 48. So this is what we did on the whiteboard yesterday. There's also a way to do this in your calculator, but you can find any multiples you want. What do y'all want to use? 4 and 12? We'll do 4 and 12. So this is old news. 2 2's escape. 1 2 escapes, write it down. Another 2 escapes, write it down. And a 3 is stuck. You can't write your answer like that. You need to combine it. So that's where we get 4 root 3. And then it also asks for the decimal version. So you need to do 4, well, do the original. Don't put 4 root 3 in your calculator. Do 48 in your calculator. And we're rounding to the nearest tenth, so that would be 6.9. 6.9. Number 12. This is a rectangle with a diagonal drawn. So Pythagorean theorem says a squared plus b squared equals c squared. 16 plus 36 equals c squared. 52 equals c squared. And then the last step of Pythagorean theorem is always to square root. And then you would need to factor tree. 4 and 13. 2 and 2. 2 root 13. So that's number 12. Okay. 16. I'll do 16, 19, and then 20. 16. What kind of triangle do we have in number 16? Number 16 is an isosceles triangle, 4 and 4. Very good. We also have the altitude drawn. We know that when you draw an altitude in an isosceles triangle, that it is also a median. So we know that when we find a leg of that triangle, that leg, we can double it to find x. So you can only use Pythagorean theorem on right triangles. You got to find a right triangle. If you don't have a right triangle, you can't use Pythagorean theorem. So we're going to look at the blue triangle, and we're going to do Pythagorean theorem. I'll call this A. So we've got 16 minus 1 equals a squared. So we've got 15 equals a squared. Square root of 15 is a. 5 times 3. No pairs. So a is the square root of 15. That means this one is the square root of 15. There's 2 of them, so x is 2 root 15. You're adding them. 1 plus 1 is 2. You add the numbers outside. Are we okay on number 16? 19. We've got a trapezoid. We did one of these in the notes. 11, 21, 13, 13. Okay. You can take this 11 and you can bring it down here. So this is 11. What's 21 minus 11? 10. So you've got 10 to work with. Well, this is an isosceles trapezoid, so we know it's even on both sides. So 10 divided by 2 gives us 5 and 5. And this is a Pythagorean triple. 5, 12, 13. I'm not even going to do Pythagorean theorem because it's one of your Pythagorean triples. I showed them yesterday, and if you memorize it, your life will be easier. But if you want to do Pythagorean theorem, you can. 12. Last one, number 20. Another trapezoid. What do we got? We got 12, we've got 15, we've got 10, we've got x. It's isosceles. Okay, so let's take the 10 and let's bring it here. We know 10 goes here. Another Pythagorean triple. It's 3, 4, 5, but when you triple it, it's 9, 12, 15. But remember, if you don't know that, you're in your calculator, you're doing 15 squared minus 12 squared. You get 81. The square root of 81 is 9. Then you just add them together. 18 plus 10, 28. Okay. Let's talk about what we're learning today. I touched on this a little bit when I was going over homework, but I just want to drill home the fact that if there's no right angle, if this is not a right triangle, we cannot use Pythagorean theorem. So can we use Pythagorean theorem to solve? No! Why not? Because we would need to add a right angle. If that angle's not right, that 6 and that 8 can do whatever it wants, and that might not even be a hypotenuse. So a squared plus b squared equals c squared only works if it's a right triangle. If it's not a right triangle, you're kind of hopeless for right now. So if a triangle's right, then a squared plus b squared equals c squared. What's the converse of that statement? Do you remember back to our reasoning? If the conclusion, then the hypotenuse. A hypotenuse. Hypothesis. Wow. My brain is in Pythagorean theorem mode. If a squared plus b squared equals c squared, then the triangle's right. If a squared plus b squared equals c squared, then the triangle is right. So, that's what we call that the converse of Pythagorean theorem. And I wrote it backwards on purpose. Because that's going to be useful in a few minutes. And because we're doing converse, so let's just write it backwards because converse means reverse, right? So, is that a right triangle? Does it deserve a 90-degree angle box or not? Is it a right triangle? Tani says no. So we're checking. Everyone should be checking. Is it a right triangle? I don't know. Does c squared, does it equal a squared plus b squared? Does c squared equal a squared plus b squared? And they're off by a little bit, aren't they? 50 squared, 2,500. 16 squared plus 48 squared, 2,560. And so that is not a right triangle. You now know how to tell if there's no right angle. You can tell if it's a right triangle or not. You can tell whether you get to add the box or not. So let's try another one. So let's just say, let me put this in a word problem context. Let's just say I give you 3 pieces of wood. Oh, this isn't very good numbers to use for that. But anyways, I give you 3 pieces of wood, and one of them is, we'll do inches. One's 13 inches, one's 85 inches, and one's 84 inches. Could you make a ramp out of those pieces of wood that would be a right triangle? Could you make a ramp out of the pieces of wood I give you to make a right triangle? Could you or could you not? Those are lengths of sides. So that's called a Pythagorean triple. If you say yes, that's a Pythagorean triple, and that means they do form a right triangle. So you're testing, does that squared equal that squared plus that squared? And I know you know this, but how do you figure out which one is C? How do you figure out which one is your C in your a squared plus b squared equals c squared? No, there is no hypotenuse. The longest one, the largest number. Yep, the biggest one. This was our C. It's the biggest number. Okay. So wait a minute. What happens when we conclude it's not a right triangle? What are the choices? What can it be if it's not right? But Albert, there's no right angle, Albert, so you can't say that. Yes, it can be acute or obtuse. Very good. If it's not right, it's either acute or obtuse. So now we need to figure out, I give you 3 side lengths, and you tell me, is it acute, obtuse, or right? How are we going to do that? Let me go back to this one real quick. We agreed that this one is not a right triangle. It's not. So that means it's either acute or obtuse. Which one is it? Is that triangle acute or obtuse? How do you know? What do you think? How are we going to figure it out? What number is bigger? Take a look at what happened. What I did was I took a perfectly right triangle, 6, 8, 10, right? 6, 8, 10. And I took B and I drug it over and I turned it into D. And now my hypotenuse is much larger. What do you think is the difference, the relationship between BC and DC? Obviously, the hypotenuse is, well, it's not a hypotenuse anymore. The side, BC, is smaller. The side got bigger. And that is definitely an obtuse triangle. So as you get more obtuse, this hypotenuse, which isn't a hypotenuse anymore, gets bigger. The C, it's all about C. The C gets bigger. What if I tried to make my triangle more acute? What if I took the 6 and I drug it this way, and I'm trying to make an acute triangle? What happens to the C? It's obviously shrinking. The C, as I get more acute, the C is getting smaller. The C is. So we're only looking at the side called C, the biggest side. We're looking at what happens to it. Now, unfortunately, we can't just look at how long the side is. We need to use Pythagorean theorem to help us. We have to look at how long the side squared is. So we're going to focus on C squared and what's happening to C squared. So, if it's a right triangle, we know what's behind here. C squared equals a squared plus b squared. If it's an acute triangle, then what? C squared less than a squared plus b squared, very good. And if it's an obtuse triangle, c squared is greater than a squared plus b squared. This slide is the lesson right here. So I'm going to give you a second to write it down. This is the lesson. Try these 4 examples. And then I think we'll take our quiz after this. Let me see. Yep. Austin, number 1. Quan, number 2. Carson, number 3. Helaman, number 4. Helaman, you haven't said anything in the chat today. You're usually more vocal. I guess verbal would be the word, vocal, verbal, because you're not really saying it out loud. Anyways, go ahead and write your answer when you're ready. Austin says right. Yeah, number 1 is a Pythagorean triple. 5, 12, 13. But let's pretend you didn't know that. You're going to put c squared here. You're going to put a squared plus b squared here. C squared is 169. 5 squared plus 12 squared is 169. Since they equal, this one is a right triangle. Always put c squared first. Always put c squared first. Always put c squared first. Carson, obtuse. Okay, so we've got c squared is 9, and 2 squared plus 2 squared is 8. 9 is bigger than 8. That's a greater than sign, so obtuse. Good. Oh, you said acute? So if you see a greater than sign, it's obtuse. Greater than is obtuse, and less than is acute. Greater than obtuse, less than acute. Greater obtuse, less than acute. So number 2, 15 squared. 2, 25. 12 squared plus 10 squared. 2, 44. This one that's the wrong sign. I knew it as I was doing it. Eat the bigger number. It eats 244. That is a less than sign, so that one is acute. Okay, Helaman, on that last one, which one is C? Helaman, which one is C? Is it 5? Is it 2 root 3? Or is it square root 2? Good. 5 is C. So C squared, this is the biggest number. I always circle the biggest number. It kind of helps. Okay. So C squared is 25. A squared plus B squared. Ooh, I'm going to need to do a little bit of work. 2 root 3 squared plus root 2 squared. So that's 4 times 3 plus 2. 12 plus 2, 14. Obtuse. 25 is greater than 14. C squared's bigger. When C squared's bigger, it's obtuse. Start your quiz. Go.